button, and we are in the process of going live. Oh, I should record this locally as a backup. There we go. Now, if you're in the chat, say banana so that we can make sure that everything's working. And okay, so I have hello everyone. Welcome to Fly.io live streaming how to scale your model. I have Annie with me here, and I'm Z Iaso, and today we're going to have fun?
Question mark? Are we?
Exclamation
Question
point.
mark? Have fun? Yeah.
Okay, my preview just skipped 27 frames, so that's encouraging.
Cannot look at the preview. It is too confusing. I'm not used to this.
I mean, the YouTube view is actually a lot more confusing than Twitch, but I have like way more experience with Twitch, so.
Wait, is it? Yeah, it is.
Okay, so
Oh yeah.
today we're gonna talk about the fun of large Langle-Mangles. And specifically
That's
how
a
to do them
technical
with
term.
llama. Yeah, that's the technical term. Yes. And specifically how to scale them in production with ollama, or tagline Uber for running large language models for you. So about half the reason that we're going to use ollama for this is because using ollama is super easy, and the other half is because oh, I forgot what I was going to say. It's just really easy to get started. You just download it, you run the thing, and it just works. Like,
I will say I was very intimidated when I first got started. I was like, "Oh, this sounds complicated," and then I ran it, and I was like, "Ah, well now I feel dumb for having not tried it before."
Right. I didn't set up wireguard in this WSL VM. Heck.
Turn on. Okay, so it's set up WireGuard.
Oh, let's do that real quick then. Yeah, fly org list. Fly orgs list.
Do you have it downloaded?
Oh, right. This has the incredibly broken setup. Right. I don't know what I did, but I made my WSL setup for the Fly CLI really broken. And every time I do something, I have to authenticate with the browser. I was going to file a bug about this the last time I streamed, but I forgot to, so. Okay, fly wireguard create -- help personal YUL test Shipra, which is Lojban for test.
I see 4 users. Yes. Y'all should say hello.
Oh, I do remember the password that I chose for the pseudo password for this WSL VM. Okay, so now sudo wg-quick. Hello, Brian Eft. Welcome to the stream.
Hello.
Wait. RT Netlink answers no such device. What? Oh. IP adder. Okay, it didn't add the ton.
This isn't for WireGuard, is it?
Yeah, I'm getting an error that I've never seen before. Okay, so Netlink is the type of socket that lets user space communicate with the network stack and the kernel.
Okay.
Asterisk. So let's go over to StreamFox and type in WireGuard IPv6 RT Netlink answers no such device. Oh, It's setting the MTU too low? The heck? I just realized that I can't actually view that configuration file on stream because it has a private key in it. So let me do some off-camera mining real quick.
Okay.
Okay,
Magic.
so MTU wireguard conf. It goes in under the interface, so MTU TU equals 1280, which is the minimum MTU for IPv6. So let's see if that does it. Hey, that is a strange bug. Let's add that in the list of bugs to file for this stream. I'll just have that as a notepad document over here. Call it bug list. WireGuard MTU was too low by default on Ubuntu 24.04 in WSL. Needed to set to 1280 manually. Patch fly cuddle to put this in for you. There. And now I'm just doing a quick update of all of my homebrew packages in Linux. Yes, you can run homebrew on Linux. It's actually really convenient. I would suggest doing it if you can.
How come? Wouldn't I feel like apt-get is like the go-to? Is it
Well,
not?
Homebrew has newer packages, and you don't have to package it in a Debian package. And Debian packages
Okay.
are suffering.
Oh, are they?
Oh, yes. Okay, so... apps? Oh, list. Right, it's not Heroku. You don't just do Heroku. You can't just do fly apps.
No. No, right?
Okay, clear. Okay, so the Ollama instance we're probably going to use is this GPU recipificator one. I think that's the one that I have set up for this. Brew install Ollama. Oh, I I asked it as a question and I typed it as a question. Okay. Oh, export Ollama host equals http://gpu recipificator.flycast. No such host. Wait. 10.255.255.254.53. Oh.
Do you have the IPs allocated?
Oh my goodness. This is the DNS server that the Windows subsystem for Linux uses. So I'm just going to IPs list -a. This is one of those problems that I will have that you will not. So what I'm going to do is I'm going to change the host to the IPv6 address directly.
Okay.
And when you're doing an IPv6 address in a URL, you need to put the IPv6 address in square brackets.
Oh, I didn't know that.
Oh, missing port and address. Okay. I guess it needs to have a host and a port. Invalid port specified in Ollama host using default port equals 80.
Is it going to be 80 or is it going to be what Ollama was running on?
In this particular case, I have it set so that it points to port 80. Or wait. Oh, I have it .flycast. Oh, that's why it was breaking. Oh, when you have a direct IP address, is the goal right now to run Ollama on a fly machine? No, I am just
Yes.
trying to make sure that I am able to access Ollama at all, and I am.
Yeah, because it's right now it's running on a private network. It's not publicly available, so
Yeah.
we're working on getting that set up.
I
Because you
am
can yeah.
I am decrufting one of my previous experiments. That's how you that's the fancy way to say it. Okay. So we have ollama and we do ollama run llama 3.1. Oh, I need to update ollama on this.
Is this local? Is that what I'm saying?
This is not local. This is
Okay.
local. The ollama client is on my machine, and the GPU is in the cloud. So I'm gonna make dir GPU dash recipificator, and then fly config save dash error GPU recipificator. Fly deploy. You're talking to an anime character. This is wild. Welcome
No,
to the future.
what you don't understand, y'all have not met Z in person, but this is actually what they look like. They actually, it's pretty incredible.
Yeah, I have a human disguise for when people expect to be talking to someone human.
Yeah, it's the human disguise is very convincing, but they actually look like an anime character. So
Yeah, this is
cool.
yeah, I'm a corporate VTuber. Okay, so ollama run llama 3.1. And oh, right. So the reason that we're pulling this at over at like 10 gigabits is because this is ollama is running on a data center grade GPU, and that is connected to data center grade internet in a data center, so it's going to be fast, and it's loading about 5 gigabytes of weights, and it's going to use like 6 gigabytes of RAM or something. So we ask it the hello world question, why is the sky blue? And we see set verbose. How many tokens per second are we getting? We're getting EOF. That's a good thing to get. I say, lying.
Okay, so Z, recap for the people listening. You're running ollama run, and where's this running?
Okay.
Tell us what we're looking at.
So what you're looking at is the ollama run that starts a model and gives you an interactive prompt so you can ask questions and get answers. In this case,
Okay,
I'm using that to verify that things are working and to get the eval rate. And the eval rate
is this running?
This is running in the
Sorry,
cloud.
Go ahead, G. It is, okay. It's on a machine.
Yeah, specifically it's in Chicago.
Yes,
on
so we
an
have
A140
like a number of,
gigabyte.
Right, we have a number of regions that have GPUs available. So if you want to try them out, just I think our docs list the different regions in them.
Yeah.
But yeah.
ORD has the most GPUs. And I think ORD is like historically one of the first regions for stuff. It's our US East one. Except it's in the center of the US. Either way, ORD has the most GPUs, and it specifically is the only data center in the world for us to have A140 gigabytes. There are L40S GPUs in Seattle and ORD, and I don't remember where else. But either way, we have a GPU, we have large language model inference, and we can see that we're generating things at 110 tokens per second. Which, for context, a token is about 3/4 of a word on average. And most court reporters can top out at like 220 words per minute of speech transcription. So 110 tokens per second is very fast. That's like about 5 to 7 times the rate of normal human speech.
Yeah, when you saw it spit out, it was pretty incredibly fast.
Yeah. So this is our baseline. As a baseline, we have one user asking one question and getting one answer really fast.
Awesome. Okay, so we have this running on a fly machine, which again is just a virtual machine, and we've got a GPU attached to it, so
Yep.
it's able to provide the muscle that we need to run these models. So what are we doing from here? Are we going to scale this?
Yeah, let's see what it looks like when we have multiple users connected to the same GPU. So, llama, or actually, do I have tmux installed? I do. Okay, cool. How do you get the stats report right after the prompt? Okay, so there's this dash dash verbose flag here, and that is what enables the statistics reporting. So if I say yes, and it will say yes back, and that it will print the results. The dash dash verbose flag is what gives you like the total duration for inference, the amount of time it takes to load stuff, the prompt evaluation time, and the evaluation duration. Did you just deploy the llama Docker image as the fly app and SSH into the machine? I did not SSH into the machine. I am connected over WireGuard.
Where are we now? Oh, okay, yes.
Let me. Here's the fly.toml I'm using. Or wait, actually, do I have Vestsun code open into this thing? I am sorry. I sometimes slip into. I have a very mild RSI, and one of the tools I use sometimes is speech to text, and it has its own alphabet that is completely different than the alphabet that you are used to. And as a result, I will say I will accidentally start speaking in that alphabet because I got used to speaking in it. I can't spell anything for anyone anymore. It's great. OBS just claimed it crashed, and I'm not going to touch it, and we're just going and
Yes, exactly, Brian. You got it.
Okay. Ollama is just listening on port 80 over WireGuard. Yeah, Ollama isn't listening on port 80 over WireGuard, but it's running on Flycast, and that has the router listening on port 80 to wake up the Ollama VM on proxy it to port 11434, and then it will just put it back to sleep when I'm done using it. So fly mlist. It's been a while. Actually, it's not been long enough. After a while, it'll just go back to sleep. Let's...
Yeah, so internally, the internal void is that 1141, but then it's exposed to port 80, yeah.
How do you create a new window in tmux? Split. No, what's the split thing? I have tmux customized, and I don't remember what the default tmux keybinds are. B %? Yeah, there we go. So what I'm going to do now is I'm going to do ollama run llama 3.1, and we're going to have 2 models loaded. Oh, right. I need to set the ollama host, right? Let me just... Okay, it has that. Where is the ollama host, though? Oh, there it is. Okay, export, paste. Export in bash just is for taking turning a shell variable into an environment variable. Okay, ollama run llama 3, and then over here ollama run llama 3.1. One of the things that ollama added recently is the ability to run multiple models at the same time on the same GPU.
How much does that impact performance?
Let's find out. I'm going to set verbose and write me a long essay about the ethics of egg consumption. Okay, so that's going to go, and just going to copy this. Watch llama ps 0. And are you actually running, or are you broken? Okay, there we go. That's set. So if I have two things going on at once, it crashes. This should not... Oh, here we go. I actually have two things running at once now. Perfect. It's not doing verbose. Crap. Okay. Dash
It's not?
verbose.
Or is it just not done yet? Oh, you're right, it's not.
Yeah. Why is it crashing? This is not what is supposed to be happening. Okay. No, if it does that, then okay. Okay, now that there's multiple things going on, you can see that the evaluation rate has taken a dip on the left side and on the right side. So when you're inferencing things, it is a bit slower because there's multiple things going on at once. Generally, GPUs are... I don't even know why we call these GPUs, because they can't actually process graphics, but GPUs are highly parallel devices. And large language model inference is a very highly parallelizable task. So...
Okay, so here's a question about the scaling. So we have this ability to run multiple prompts on the same machine with the same GPU.
Yeah.
How does that compare to... I mean, I would imagine... Obviously, I think it would be like much faster if you were just scaling to multiple machines, but that costs more money. So I guess there's a bit of a trade-off there. You can choose to have it all run on the same one, but then you sacrifice a little bit of performance.
Yep.
But also having multiple machines means like you can do it in different regions. So that's something to consider.
Yeah, a lot of this is going to boil down to, wow, there are a lot of trade-offs. I would draw things out on Excalidraw like I had prepared, but OBS claims to have crashed, and if you do not touch OBS after it claims to crash, everything will continue working, but the second you touch anything related to OBS after it does that, it will crash. Hard.
It's okay. I can do an interpretive dance if you'd like. I can show the people what we're talking about.
So what I'm going to do instead is I'm going to open Vim, and we're going to do this the hard way.
All right.
Okay, so I have just realized that my mind went entirely blank because I was expecting on being able to draw this. So we are like in real struggle hours right now. We are in real struggle hours. Oh, God. Okay, so... scaling your large language model apps. I'm like Pirate Software, but I use Vim instead of MS Paint. So... One of the main hard barriers here is that large language models inference, as I said before, is both like compute and memory intensive. Generally, with a lot of stuff that you run in production, you have things that are one of the three following categories. It's either compute intensive, memory intensive, or IO intensive. And large language model inference is really weird because it is both compute and it is like compute, memory, and IO intensive. Or actually, would memory bandwidth count as IO? Let's say it counts as memory intensive. Yeah, one of the main factors on why running large language models on a GPU is a lot faster than running it on a CPU is not actually because the GPUs are good at parallelism, like I said. It's because that large language model inference requires a lot of memory bandwidth. And my tower right now has a memory throughput of like 30 gigabytes per second or something. It's an older computer. It's got DDR4 memory in it, so it could be faster if I upgraded. But the average A100 is like A100 memory bandwidth. Yeah, 2 terabytes per second. Holy crap. Holy crap, I did not expect it to be that high. That's like...
Whoa.
3 powers of 10. No, wait. That's 2 powers of 10 faster than my desktop. Okay, that is way bigger than I thought it would be. Oh, the A100 that I'm using in this only has 1.6 terabytes per second of memory bandwidth. But either way, it's memory bandwidth intensive, as well as memory intensive, as well as compute intensive. And historically, this is kind of an edge case when it comes to scaling things. So a lot of the scaling, I guess, would depend on how many trade-offs you want to make.
Yeah, so what kind of trade-offs would those look like?
So, like, the trade-offs that I can think of are, like, latency and cost. Where the latency is the, like, amount of time it takes to go from question to answer, and the cost is the amount of money you pay for all the GPU time. So... cost for all the GPU nodes. There we go. And... So... Actually, let me hit Control Plus a couple times. There we go. I think that'll do it. I would love to adjust things in OBS, but it crashed, and I'm not touching it. So... one of the other things is that LLM inference is memory bandwidth intensive. And being memory bandwidth intensive is kind of unusual for, like, a lot of things we're doing. Cerebras CS3 has 21 petabytes per second of memory bandwidth. Holy crap.
Whoa.
That would... depending on how big the memory bus is, and if, like, transformers can be put onto there, that could get you inference at, like, yes tokens per second. Like, I'm not even doing the math at that point. It would just give you, like, if like, 1.6 terabytes per second of memory bandwidth on a card that's technically 3 years old gave us, like, 110 tokens per second on an 8 billion parameter model at 4-bit quantization, then an 8 billion parameter model at 4-bit quantization on that would give you, like, potentially the entire context window in a second. Or, like, over 128,000 tokens per second, I think. If I'm doing my math right. Probably not. Okay.
Can you say real quick, can you say more about when you say it's unusual for many other kinds of tasks? What other kinds of tasks are you saying, like,
Okay, let's
other
most
Mhm.
of the time in your career you work on web apps, and the web app is really just like a crappy interface to a database, right?
Sure, sure.
And most of what your web app is doing is like taking in a request, converting it from the wire form to some internal representation, like parsing the JSON into a structure or an object or
Mhm.
whatever, and then doing some business logic to determine if you're allowed to do something, and then interacting with the database and returning the results.
Sure.
And that is not exactly memory intensive. That
No.
is more of IO intensive because you're reading the request from the user, you're doing a request to the database, you're reading the response from the database, and you're massaging that into a response for the user.
Got it. So it's the type of task that when you're building in an application, it's not something you would typically, I mean, if you're building like a simple like SaaS, not even simple, even a complicated SaaS app,
Yeah,
you're not necessarily going to be seeing this kind of like memory intensive work
yeah,
unless you
because
start to work with something like LLMs. Yeah.
like you don't need to be overly memory intensive to convert requests into responses from a database.
And if you do, you're doing it wrong. You're doing something wrong.
Okay, there are cases when you would have a high memory
Sure.
database flow, but I can think about like one time that I've seen that in my entire career that wasn't a bug.
Yeah, I listen.
Yeah.
I did my time in the support engineering trenches. I've seen how people can mess up their apps.
Oh god. I still think one of my favorite ones was I I remember hearing tales about GitHub back in the day where they kept running out of RAM even though they had like this was I think this was back in like 2006 where they had machines with 128 gigabytes of RAM to run their Rails app because their Rails app wanted to
What?
load the entire database into memory at all times.
What?
Yeah.
Okay.
And that would classify as a bug in my book.
I think that just sounds like a poor decision. I would not call that a bug.
I mean,
That sounds like a choice. Like
bugs
someone's
and
like,
poor life
yes.
decisions are basically the same thing because you track them both in Jira.
They're usually unintentional. That seems like an intentional choice. Like,
Bugs and
yes,
bad
we're
life
gonna do
decisions are
this.
both the
We're gonna
same thing
carry
because you
this whole
track them
thing.
in Jira. Yeah, that's a great quote. Can't wait to see that on TikTok. Okay. Memory bandwidth intensive. Yeah. And
Okay, yes.
most of the time things are like IO bandwidth intensive. I don't write bugs, I intentionally make bad decisions. Ah, that's a mood. But most of the time things are IO intensive. Like you're
Yes.
reading stuff, you're writing stuff, you're doing stuff on the file system, you're doing stuff on the network, which is also the file system in Linux. It's complicated. But large language model inference is memory bandwidth intensive because you have all of these weights, all of these floating point numbers, and all of these layers, and you effectively take all of the tokens as input and you mix them through the different piles of linear algebra, and you get one token of a response, and then you add that to the end of the context window, and then you shunt that through the piles of linear algebra, get another token, add that to the thing, shunt it through, and so on in a giant loop.
All in a day's work.
It's just like Hofstadter. It's a strange loop.
Okay, so memory bandwidth. What else? Say more.
Um, a lot of the other decisions are that you make for scaling are just based on latency, because realistically, most of the other scaling laws don't apply here. Most of the time, when you want to scale something, there's like several different. There's two main methods of doing it. It's called horizontal scaling and vertical scaling. Vertical
Mm-hmm.
scaling is when you just throw better hardware at it, and horizontal scaling is when you throw more hardware at it.
Yes. So it's a matter of like, do you have more muscly or do you have more people? Like
Yeah,
effectively, like if you're gonna move a bunch of stuff, you can either have someone who's much stronger and can pick up an entire refrigerator, or you have like 10 people to help
that
you.
can pick up a
It's the same
refrigerator
kind of thing.
together. Yeah.
Right.
Yes. And we can't really do vertical scaling that much because like there's only like what 3 models of GPUs, and the A100 is the top model, and the only advantage you'd get is a bigger more video memory, which does make a difference. Like the A100 40 gigabyte model that I have in this llama instance isn't able to run like a 70 billion parameter model, but it can run. But if I upgraded it to an 80 gigabyte model, it would be able to.
Mm-hmm.
Actually, 70 billion parameter at int 4, that's 35 gigabytes of weights. Oh, the scaling law. Right, I'll write out the scaling law.
Yes, please.
So, what I'm about to tell you is a back of the napkin estimate for how to figure out how much VRAM you need. This is not going to be a perfectly accurate way to do this because facts and circumstances can and will change this. But to give a very rough estimate of will it blend, you take the parameter count of the model times the parameter size, add 30%, and that's roughly the VRAM you need. So
what do you mean by parameter size? Like the parameter count would be like the 7B or whatever the size of parameters that's like listed on the model. What's the parameter size?
So let's see if okay. So we have llama 3.1 here. It is a llama model. It has 8 billion parameters, and then there's this quantization bit here. Quantization, or a model, is basically a giant bag of floating point numbers. And by default, when these models are shipped, they are shipped as 16-bit floating point numbers, or float 16. This means that every one of those 8 billion parameters takes up 16 bits of space.
Okay.
And that would be like...
I'm sorry, where does it say that? The 16-bit?
It doesn't say 16-bit here. It's just like this is how this stuff works.
Okay, this is just real facts.
Yeah, when
facts. Okay, cool.
when like Facebook ships the model, they ship it as a float 16 model, and then people will quantize it down to smaller weights. So what this quantization thing means is that this model is not the original floating 16 weight float FP16 weights. They translated those weights lossily to a smaller number size so that you can fit it into a smaller GPU. So
got it. And case, what are you giving up in that case? So if they're sort of compressing it to some degree.
The beautiful part is that we don't really know what we give up when we do this, but people currently believe that in the process of quantizing a model, you end up losing out on subtle nuances.
Yeah, I would believe that.
Yeah. I don't have a good answer for you here because, number one, we don't know how knowledge works. Number two, we don't know how AI stuff works. And number three, we don't know how AI stuff and knowledge works in concert. So, like, any speculation we have as to what quantization actually does to a model is that speculation. But I currently believe, and if you know me, saying that I believe something is a very strong word, that a quantized model will perform slightly worse in ways that are very hard for you to figure out.
Yeah, it seems like something that'd be like imperceptible unless you used a particular model for a particular thing many, many times. And even then, like, meh. Yeah. I mean, I think that like if... But okay, so Is that a thing that like most people need to worry about of like the parameter size, or not the parameter size, the
The quantization?
quantization? Like, do most people need to worry about that, or are they fine just using like the, I don't think compressed is the right word, but the, for lack of a better word, like the compressed version of it? Like,
Yeah, the main
I don't know how
reason
much it.
that llama quantizes the models down to 4 bits by default is so that they can fit into consumer GPUs. And NVIDIA is notorious for not giving consumer GPUs enough VRAM. So the quantization allows it to be possible to run things on like
Mm-hmm.
consumer grade hardware.
Mm-hmm.
Um, I personally,
Interesting.
when I do a lot of my large language model stuff, I use Q4 because for a lot of the stuff I do, I literally cannot notice the difference. If I'm doing something more like hardcore, I would probably quantize it a bit. I would probably use like float 16 if possible. But if not, then, running it with whatever works. It's really a
Got it.
trade-off between it working at all, it being fast, and other things. Actually, let me grab the Llama 3.1 8 billion parameter float 16 model so that we can see a difference here. Here we go. It's called 8b-instruct-fp16. So, as you see, Llama 3.1 colon latest is 4.7 gigabytes of weights. Let's see how big the floating point 16 model is, because it should be about 16 gigabytes, right? Because it's 8 billion parameters times 16 bits divided by 8, that is 16 gigabytes. You can have just a bit of quantization as a treat. Yeah, 16 gigabytes.
Yes. Yeah, quantization only on a cheat day.
I'm going to need to remember to /set verbose so that I can show that it... Actually, I don't know if Q4 is faster than float 16. We're both going to find out. Because my first instinct would be to say that Q4 would be faster to inference than float 16 because it's a smaller data type. But then I remember that the A100 doesn't have 4-bit integer support natively, so it's being emulated with software. So we're going to find out. Yeah, there's lots of weird trade-offs, and a lot of this is stuff that there's not really sufficient, like, industry best practices for, because this is all so new that I am someone who is paid to keep up with this stuff, like, professionally, and I can't keep up with everything. And, like, if I can't keep up with everything, I have no doubt that other people can't keep up with it, too. So now that it's done, we're gonna load it and do /set verbose. And it was about 110 tokens per second at Q4.
Ooh.
Every day, so much research paper. It's crazy out there.
Yes.
Oh, it's down to like 58 tokens per second. Okay. I guess it does have 4-bit integer math natively. Today I learned. But yeah, the 16-bit floating point models are probably more precise, but I don't know if the distinction really matters at like smaller scales.
Yeah. Brian F is saying that if it's heavily quantized, then you'll
Yeah.
notice a difference. But I'm not sure what heavily quantized is. Like, what would be considered heavily quantized?
Well, probably 4-bit from 16-bit, because that's like throwing away
Mm-hmm.
12. That's like throwing away 75% of the precision.
Makes sense.
I guess another advantage with quantizing models on cloud GPUs is that you can put multiple models into memory at once, like Llama 3.1 and something like LlamaGuard.
I learn new languages just to read research paper from other countries. I have a friend who has synesthesia and works for. Actually, I don't know how much they're comfortable with me sharing about them. But anyways, the point is they have synesthesia and they read documentation and stuff specifically in Chinese so that they can read it easier because, and they're like native English speaker, and they don't really speak Chinese, but they use that because it's easier to read. Anyways, fun fact. Yeah, but I feel like in order to keep up, you'd have to expand your language knowledge.
Yeah, I have been trying to relearn Chinese partially to keep up with papers because some of the big papers are actually like from mainland China and in
Yeah.
Chinese, but 我不会说中文.
What? Let's see. Actually, yeah, that's the only phrase I know how to say. 我不会说普通话.
Yeah. Yeah. Basically.
By the way, everyone has to learn at least a few phrases in Chinese to work at Flight.io. That's the rule. So.
是的吗?
Yes.
Yeah.
对.
Yeah. Okay, so yeah, you can definitely see the difference right here with like the Llama 3.1 at Q4 versus the Llama 3.1 at floating point 16. It's like 4 times as large, which you would expect for it being 4 times as many floating point numbers. I don't know how their rounding code works, but if it's using the Go library, I think it is. I think it's doing kind of lazy so that it looks nice to humans. I lost my train of thought. Where was I in Vim?
Well, we were talking about being able to run things not in parallel. It feels weird to say, like, you can run multiple models in parallel, but then things run parallel on a GPU, whatever. So yeah, you can run multiple prompts at the same time.
Yeah, and even on different models.
Mm-hmm. Oh, so you can be running... How does that? I guess I don't really know behind the scenes when you're doing like llama serve. You've got this HTTP service. You want to generate something. You can have multiple models running inferences at the same time. Is what you're saying?
Yeah.
You can have like Llama 3 and Lava and Mistral and whatever.
Yeah, I just loaded up some more
whenever.
models into memory, and as you see, you know, there's like Llama 3.1 with 2 attention windows, so it's using like 7 gigabytes of RAM because of the extra add 40% head math.
You know what's interesting? With like a typical, like we were talking about, like typical web applications, or like the problem is not the problem, but like a bigger consideration is like IO rather than memory.
Asterisk.
But yeah, right. Yeah. But it seems like I'm getting the sense that, like, okay, yes, you can run multiple inferences at the same time on these GPUs, but it seems like the cost is higher compared to like accepting a bunch of requests or something like that. Like,
yeah,
it seems like you would want to lean more. Tell me if this is true. It seems like you would want to lean more on scaling the number of machines rather than like having a single machine with a GPU running a whole bunch of stuff, because it seems like there's, I don't know if I would call it non-trivial, but like it seems like it would scale up. Like the impact on performance would be very noticeable very quickly if you tried to shove a bunch of stuff.
I mean, it really depends on what your service level objective is.
Yeah, that's fair.
So
that's fair.
Yeah, I'm going to be breaking out some SRE speak here, but by service level objective, what I mean is
That's an SLO.
Yes, I have religious beliefs that preclude me from using unnecessary acronyms.
Okay, I'll use them for you.
So when you're running large language model inference stuff in prod, you generally want to have a arbitrary line of how fast is too fast and how slow is how fast is fast enough and how slow is too slow. And one of the ways that you can track this is the number of tokens per second that are generated, or the latency from request to response. Latency driven or throughput driven. which are two terms
Mhm.
that I have completely made up.
It makes sense. I follow.
Yeah. So a lot of the times now, whether you want to be latency driven or throughput driven depends heavily on what is the use case.
Mhm.
Like if you're having something that's directly connected to a user, then you probably want to be throughput driven because users will notice when things are slow up to a point, because the
Yes.
average human reaction time is about 250 milliseconds, and even trained humans have difficulty getting below 200. And that is specifically for the reaction time from eye to brain to brainstem to arm to fingers.
Sounds like a skill issue to me. All right.
I mean, like, I would really love to see like trained speedrunners for games like Super Metroid go through reaction time testing, because I think that they may actually be able to be faster, because Super Metroid does require some pretty fast reaction times.
I mean, I would believe that. Okay, what is the use? Yeah, what is the use case? So latency driven or throughput driven? Got it. Yeah. Um. Cool. And so that latency, just for people catching up, latency driven. We're talking about like it comes back to that question of, do you throw stronger muscle at the problem, or do you throw like more people at the problem?
Yeah.
Um and so it's that question of like, well, is it worth trying to run multiple inferences on the same machine with the same GPU? Are you okay with the latency, like the performance hit, or if that's intolerable, is it better to have more machines that can run things? It's kind of like the
So let's
it feels like a bit of like a latency, throughput, cost, pick two. Like
yeah.
it's sort of one of those triangles, right?
Yeah. So let's say, for the sake of argument, you have a search engine, and part of your search engine is you request each of the pages and you get summaries if the summary doesn't already exist in your system.
Hmm.
So you can use this to give the user a summary of what's on the page so that they can decide if they want to click on it or not. For this, it may actually be better to have multiple summary jobs going on the same GPU, because, well, it's going to just get live updated anyway on the user page, right? And then it's going to look magical for it to have multiple things at once, and people will tolerate the higher latency because of the magic UX.
Hmm.
I guess that's actually getting into like user psychology, and that's a completely different argument than a lot of this other stuff. Let me grab a random file from my blog real quick, and or a couple random files from my blog's GitHub repository, so that we can have the large language model summarize them. 128,000 tokens, so I need to avoid articles that are more than... Actually, I don't need to worry about it at all. 120. None of my articles are bigger than 128,000 tokens. And a token being about like 3/4 of a word means that 128,000 tokens is enough for, I want to say, like 1.5 English language novels. Sounds about right? Because a
Wow.
novel is 50,000 words according to the National November according
NaNoWriMo.
NaNoWriMo. And that's about 75,000 tokens, because a token is about 3/4 of a word on average.
Hmm.
I think that does it. Let me find a couple of them. Yeah. Okay, so copy, and then I'm making a folder called temp. The meaning of temp is an exercise for the reader. Gonna grab this file. It is an MDX file. If you've never seen MDX before, it is kind of evil and amazing at the same time. It is Markdown mixed with React. What are your thoughts about that, Andy?
Markdown versus React? What
Markdown
did you
mixed
say?
with React.
I do that all the time.
Ah, okay. Usually technologists have like very detailed opinions about that.
It gets a little confusing, but I don't know. I think that, yeah, MDX is what I use. It's I think it's really useful. Like doesn't Astro have really good support for MDX? Astro is my new favorite framework.
I need to make Gremlin kit, right?
I need coffee.
Yeah, coffee is nice.
I hope folks will not mind me making a little bit of coffee right now. I'm still here. I'm just gonna do this. I don't. Z, how do I mute myself so I don't
You just go into the Google
burn?
Meet thing and hit mute.
Oh, Google Meet is where I would mute myself.
Yeah.
Okay. Okay. Hold please. I'm still.
Why is it EOFing here? Okay, so let's take a second and let's figure out why this is crashing, because this should not be crashing. So what I'm getting is an EOF error, or end of file, and that sounds wrong? Okay, let's see if it's somehow related to the floating point 16 model. And let's run the... Are there any logs that are helpful here? No, there are no logs that are helpful here. Oh. No, why are you doing this? Error post API generate EOF. Is it because I'm... Okay, let's dump this into the thing and let's directly paste the contents of this article, because let's see if there's like something going on with how bash is working. Okay, so then triple quote, summarize this article. And then paste. You're about to paste text that is longer than 5 kilobytes. Do you wish to continue? Yes. Okay, let's see if this crashes, because if this crashes, then we have big... What the hell? Okay, what is going on? What the flippin' heck? Gosh. Okay. Fly M restart. Let's just reboot it. If all else fails, turn it off and on
All
again.
fails. Yes. We're professionals. Yes, we're not to be.
Have you
Okay.
tried turning it off and on again? Are you sure it's plugged in?
There's not like some dumb stuff with like quotations that's screwing it up, is there?
There shouldn't be. I mean, that's the other thing, but like, it shouldn't be possible to like get something that causes an EOF error.
Okay.
Okay, let's be a bit more rude now. Let's no, I want double quote. Okay, so control B double quote. Fly M list. Let's connect to the machine directly over IPv6. Let's be less kind. Let's be very
That's
rude.
so rude of you. That's so rude.
Oh yeah, you know it. Equals http:// and then paste :11434, which is the llama port. And then because we have this watch command running in the background, the machine isn't going to go to sleep. So let's see if it's somehow related to the fly router. I don't know how it would be, but it's not crashing here, at least. So that's something that has changed. Welcome to Z streaming. Half of it is doing the thing you want, and the other half is everything breaking and having to figure out why it's broken.
Well, I feel like this is a great way of debugging because
Yeah.
there's number one, a sense of urgency. Number two, this is like the science of computers and demos is that everything breaks when you show it to other people.
Well, yeah, that's why I don't like doing live demos.
But okay, here's the thing: you do live demos, and it's like the opposite, right? It's like when you do live demos, everything breaks, and then when you have a bug and you want to show it to somebody to ask questions, the moment you show it to them, it's fixed. So that's the universe.
I guess. Yeah. So now we wait some more. It's taking longer to crash if it's going to crash, which is a good sign. I think.
IPv6 reminds me of GitHub.
Oh, yeah, GitHub doesn't have IPv6 support. If you have an IPv6 native network, you can't use GitHub. You have to have IPv4 support to use GitHub.
Listen, the clock is ticking, all right? The clock is ticking.
I pay for 8 gigabit fiber, and it's IPv4 only. The only reason my phone has IPv6 is because the protocol for LTE and 5G demands that you have IPv6 support.
Why? I don't know. I guess it's just slow to roll out. Like
it's because there's no sufficient need for us to do it because not enough websites support it. And I'm like,
but like, aren't we gonna run out? We're gonna run out of IPv4.
We've already ran out.
We already have, yeah. So we've already run out.
At least we've run out of unallocated IPv4 addresses. Where things will get real when we run out of allocated IPv4 addresses.
That's what I'm saying. Clocks are ticking.
But it also doesn't help that AWS has like 1% of all of the IPv4 addresses in the world.
1%?
1%.
That seems small.
That's 1% of 4 billion.
I guess, yeah. I don't know why I would think it'd be higher.
1% of 4 billion. How many is that? That's like...
I mean, that's a lot.
Many?
It's a lot, but I guess I just thought like...
It's like 400... It's like 40 million or something.
Am I centered? I have no idea.
There's
such a delay.
Yeah, you're moderately centered.
Okay, cool. I keep moving around. I apologize.
Soon, IPv4 addresses will be ruthlessly hoarded by IT warlords like Water and Mad Max.
Like Mad Max.
Also, IP blocking is nigh on impossible with IPv6 because you can't reasonably store that many numbers. Okay, so the trick is you don't store the numbers. You store the ranges. And this is a lot difficult for existing software because existing software is written in the IPv4 days where like you expect that you can just store a single IPv4 address and you're done. But doing IPv6 address banning means you have to ban address ranges like a /64 or a /48, and that potentially can be a lot more math to do it. And banning individual IPv6 addresses doesn't work because there's address privacy extensions, which means that your computer will just randomly start rotating your IPv6 address to avoid people being able to track you via your IP address.
Maybe test of the article you want
is valid file.
Is a valid file. I mean, it's a markdown. It's just a markdown file, right?
Oh, let's check. Okay,
yeah,
file.
MDX.
Does it
matter that it's MDX? It doesn't matter that it's MDX, right? It's just
I mean, it's ASCII text with very long lines. The way that we are streaming from Google Meet is that I have OBS doing a window capture.
Yes.
OBS that has currently crashed.
It has crashed, right?
It is partially crashed.
Just don't touch anything.
Yep. Okay, so it's a valid enough file, and by valid enough, I mean like, no, that's not colon. I have a dedicated colon key on my keyboard. Yeah, so if I scroll up here, we see that, you know, like, I'm not seeing any obvious corrupted file signifiers.
I interrupt this broadcast. All right. Up. Up. Yes. Anyways, doggy cam. Arlo is here to answer your questions.
Okay. Okay, it is actually loading the model
It's
into
done.
memory.
Okay.
Okay, so it is doing something. Now the question is my article just too long? That doesn't make sense because it shouldn't be possible, right? Okay. Brew
Test but
install
verified. Test but verified.
Jake Joe. By the way, there's this amazing program called Joe, J-O. Watch this. Joe foo equals bar. It just builds a JSON object for you. It's really great. It is so great. Curl data double quote Joe model equals llama 3.1 system equals, summarize this article, stream equals false. Bless you.
Thank you. Z, is there a way for me to see your terminal in real time the way I can see it in Google Meet? Or
Not
is it
without
just am I
breaking
doomed
everything.
to watch? Ah, okay, cool.
That's what we were.
We'll
That's what I
not
was
touch
trying to
anything.
fix earlier before
Dang
this, and
it!
yeah.
Okay,
Welcome to my
it's
hell.
fine. So I'm just gonna
Welcome
have a
to
lot of
hell.
delayed reactions to what you're
Yep.
typing. That's fine.
And what I need to do is I need to go read the ollama documentation so that I can fabricate the right JSON. API documentation. So I would move over to Firefox, but again, I can't. Generate a completion system equals summarize this article and prompt equals cat dot slash oh thank you double quote command expand cat the layoff.mdx http / 3 yeah, then we get fd, or no, I need a square bracket here because everything is breaking around me. Then colon 11434 / API / generate, right? Okay, so it's not immediately crashing, so that's a good sign. Okay, so let's do stream equals true. I don't have quotation issues. Velspera says progress. Yeah, maybe. I don't fucking know. Okay. It's saying that it's using 6.7 gigabytes of memory, which makes me think it's working because that means that it's using more memory than just the weights. So that makes me think that it's actually doing something. Now, what that thing is? That's a good question. Actually, come to think of it, apply IPs list. Computer magic. I guess. Okay, so I'm going to abandon this request, and I'm going to give it the flycast address. /API/generate, and I'm going to do -v for curl. Oh, -h content type application/JSON. Is that why? Or does their API not care? I can never tell. Okay. Empty reply from server. It's sending 16 kilobytes of stuff. Maybe the summary is the friends we made along the way. No, why are you failing at this? Oh my god. This shouldn't be happening. Hold on a sec. I'm going to update llama on my gaming tower and see if it works running locally. So let me figure out what the WSL host IP is. IP adder? IP link? Okay, so the sudo apt install nettools. Okay, so what I'm looking for here is the scroll wheel to work. So I do Control
You ask
B,
too much.
page up. No, Control B, Option page up, and we have the IP of this WSL container is 172.31.217.234. And I thought that showed you the default route. Fuck, how do you escape? Wow, it's almost like I'm an expert. Let's kill the queen. CD temp. Okay, and then actually IP config, and then I can do the super cheating thing. I can see if llama listens on. Maybe set llama debug equals 1 in your fly app variables to see what happens. Sure, I've never set that before. Let's see what happens. YOLO. Env. Let's set that. Let's hit fly deploy. It's rebooting the thing. Control B, set mouse. Oh, right. Okay, this is way easier to deal with now. Holy crap. Okay, so... Oh, right. When you deploy a machine that scales to 0, it doesn't start the thing instantly. Right, okay. Okay, it discovered the GPU libraries. It got the API tags. That's good. Oh, llama run llama 3. And then it has all this stuff for llama.cpp. We found one CUDA devices. The model load progress is going. It loads the model blob from the disk. Hi. Runner with non-zero duration hasn't gone idle. Good. Okay, so now let's see what happens if we run that fancy command. Is it just not getting to the right place? Okay. What? I have to be doing something wrong here. There's no way that I am not doing something incredibly wrong. Oh yeah, there's super chill music because I have like stuff from freelofi.com playing.
I don't get free what? What? I don't get free lo-fi on my end. Boo. I
Just go
want
to the
lo-fi.
lo-fi hip hop stream and put in the background. It'll basically be the same thing.
No, I'm just gonna sit in silence.
Defiantly sitting in silence. That's
Yes.
Defiance in Silence. That's your band name.
Mm-hmm.
Okay, why is
A
this
band that actually doesn't play any music. Okay.
failing? What am I doing wrong? Am I just bad at my job? Okay. No, I don't want index. I want double quote. Control B, shift, double quote. Oh, right. That one on the other side is not a shift key because I wrote the keyboard firmware in C and don't remember what I did. Okay, now we are SSH'd into the machine itself, and I'm going to start an llama PS loop so that we have the machine staying online while we do brain surgery. We're going to install curl, and that's going to do a lot of crap. And then I'm going to generate the JSON that we need. And where is the... Oh. Where... Oh, I'm missing a double quote here. Okay. There we go. Now we have all of this JSON, and we want all of this JSON to be here. So how do we get the JSON over there? We're going to use ix.io. It's taking a break. sprunge.us. That's also taking a break. Command line paste bin. clbin.com. Okay, let's see what this does. Cool, we got a URL. What happens if I open the URL off camera? I get the JSON. That's good. cd temp wget this thing -o foo.json app or curl-o foo.json that curl-data-binary at foo.json http://localhost: 11434/API/generate-h content type application/JSON. Okay, it's doing things. It's doing things. But is it doing the right things?
It seems like an existential question.
Oh, it is generating things. Okay, that is good. That is the thing that we want to see happen. So...
Yay!
I'm not crazy, my networking setup is.
Why does this not surprise me?
I mean, like... I'm gonna be totally honest. This setup that I have is incredibly jury-rigged. And I'm not surprised that something that I did in like 20 minutes to be it ready for this stream is failing on me. Like, I'm not surprised about that in the slightest. So I'm going to vim foo.json or apt get install vim and Jake. Jake is how you pronounce JQ, and Jake is a stupidly useful tool for dealing with JSON. So it's like Jake
Pronounce it
input.
Jake?
Yeah.
Oh. I always said Juku.
So what I did here is I took Jake and I took in foo.json and I wrote the output as foo.jake.json. So what I can do is do vim foo.jake.json and we have it in nice big words. Stream false. And then we can do the curl request again with foo.jake.json. And we can output the result to results.json. Or we pipe it to Jake. And we put it in result.json. Now, it takes a second for it to think. It'll generate like 23 kilobytes of response and put it in result.json, formatted. So if we go to result.json, we see that it summarized the end of the article. Okay, but it's in dot response, so cat result.json pipe jake dot response dash r pipe less apt get install dash y less. So what this is doing is that for some reason this is summarizing the end of the article, which is sometimes a problem that large language models have that nobody really knows how to deal with. This update contains sensitive information. Yeah. Okay. Yeah, I'm not surprised that it's failing in this exact way. I swear, I try to be an optimist when it comes to large language model stuff, but then, like, everything breaks. So, let's upload another article that's longer, because now that we've proven that things work, curl-o foo.json. As you can see, I am a programmer, so I have the best names. Let's do stream false. And curl. And we want to do foo normal.json. And we want to do an overwrite thing. So what this command says is it's curl -- data - binary, which tells curl that it's going to read binary data, and the @ before foo.json says that curl is going to read from the file called foo.json, and then I have the URL for http://localhost:1143.4, which is the llama port, and I'm hitting the API generate route, which is used to generate things from JSON generate things from a large language model with the JSON body telling it what it does. I'm setting a header that says that the request body contains JSON, and then I'm piping it to Jake to prettify it and putting it in result.json. But what we can do is we can do jake-r.response and have it give the raw output of the JSON field called response. So we do this, we let it think, and I realize I need to pipe it into less so that we can read it. Less is a pager program because it breaks the output of a command into pages that your terminal can show. That's why they call it a pager.
Oh, okay then.
Break pane. I'll move this over into a new tmux pane so it's easier to read. But this is it from the article that's about me fixing my home lab setup by using Kubernetes and Talos Linux. And apparently the summary is it asking me questions about why I did things. But I guess that's fine. It's not exactly what I'd expect to get from a summary, but I think that is, like, an adequate summary, I guess.
I mean, we don't know. I mean, if unless we've read the article, we're gonna have to assume so. But
Yeah. Actually, how long is the article? 80 kilobytes. Holy crap. That is a long article. For the record, the average sheet of paper printed on both sides contains about 4 kilobytes of text.
your article is 80?
My article is 80 kilobytes. That is 80,000 keystrokes. Jesus Christ. I knew it was a long article, but I didn't think it was that long. But yeah, okay. So we have things working. And where were we before we went off the deep end?
Okay, so we were talking about the comparison between having multiple machines versus using the same GPU.
Okay.
I wanted to ask about, we have notes off screen, but you're talking about one of the hard parts about scaling is volumes. Do you want to talk about that and how do you scale with that? Like, and first of all, let's just define, why do you need volumes? What are they for in relation to this?
Okay, so as I mentioned, large language models are a bunch of floating point numbers that are stored on the disk. And and those are put into memory.
Mm-hmm.
So, like, these models right here are very big, and fly.io has a limit for the size that a model can be. Like, naively, what you might want to do is just put the model into your Docker image, and then it can run anywhere. But if you do that, then the image takes longer to pull, which means that it will take longer to get started. And if you ever have to change the image, you have to redeploy the Docker image and, you know, potentially waste a bunch of space in the registry.
Yeah, that doesn't seem like a good move.
I mean, it would work for some use cases, but like not every use case.
Right.
So
what do you do instead?
What I have is I have a fly vol list. I have a volume set up for this machine. It is a volume that a volume is basically a persistent folder that will stick around when the machine restarts. Because otherwise everything in your machine gets wiped out. That's why I did this watch loop to keep the machine awake while I was installing packages on the machine and doing like manual debugging.
Okay, good.
So this models volume is where all of my models live, unsurprisingly.
Got it.
So if it's this volume is exposed as dev VDC on the VM, and it's mounted to /root/.ollama, which is Ollama's home folder, and that's where all the models are. LSBLK.
Right.
Yeah.
Okay, so here's a question then. We've got this model attached to our machine. We have one machine right now.
Yeah.
Our app is growing. Now we want 2 or 3 or 4.
Yeah.
What does that mean for the volumes? Do we have to have more volumes? How do you keep them synced? Like, what are the trade-offs? What are the problems with that?
So one of the main problems with volumes is that they are effectively, when you create an app with a volume, you effectively maroon a machine with a volume. You maroon that particular machine to one specific computer box in a data center. And if that computer box explodes, then your machine and all of its volumes are gone. This is kind of a fundamental limitation of the volumes product. I think there's ongoing work to work around this, but if you want to spin up more volumes, you need to fork the volume to a new machine. Fly vol fork -- help.
Got it. Yeah. So I mean, like, a volume is pretty. When we say persistent, we mean persistent, and it's not. There's no like distribution baked into this, so which I think is pretty standard for volumes. But what might be a safer option if you wanted to persist your models and have multiple machines. What would be a better option?
Just making multiple volumes. That does mean that you have to keep the machines in sync somehow. Asterisk exercise for the reader. I hate saying that, but like, I, there's no real good other option. You could like set up the bottomless volumes on Tigris or something. I haven't tested
Okay, yeah,
that.
I was trying to bait you. I was trying to bait you that if you wanted to, like, volumes are one way of doing persistent storage, but there's also just like object storage, and we could do that. But I mean, we don't have to get into that today.
Yeah,
But that's
and
something to look
storing
into.
model weights in object storage does theoretically work, but I
Hmm.
am skeptical that it has practical value.
You don't think that with something like Tigris, where it's distributed everywhere, that I feel like that would be very beneficial.
It could potentially help, it could potentially hurt. The main problem is that the model weights are big, and
Hmm.
Tigris is a pull through object storage solution. So when you pull the weights from a new region, it has to pull the entire big object over the internet. And I mean, I guess it would work.
Theoretically, that wouldn't have to be done. That I mean, that's like
That only has to be done
that would
like
be done.
once per region,
However, yeah, yeah, exactly.
I guess.
That's what I'm saying. Like, I don't like. Yeah, it would be slow the first time around, but then you're done. Like, I don't know how
Yeah.
often people would be actually updating the underlying model,
Could you just set
but
up
you're right. That
NFS
is
on one
something to
machine and share
consider.
that to everyone? I think so. I don't know if guest kernels have NFS though. Oh, mod probe isn't found. LS mod? Um, hold on. Let me remember. Ubuntu mod probe command package. It's just called mod probe. Okay. No, I'm reading an AI generated page. Crap. No. Oh, it's from Kmod. Always read the Ubuntu documentation specifically. Yeah, okay. Mod probe module not found. Oh, right. Fly user kernels only have module support for NVIDIA. Everything else is statically compiled in. gzcat config gz pipe vim. No. Fuck. Oh, I have broken the output really bad. Type in reset. There we go. Cool. Cat gzcat config.gz output to /tmp/config. Zcat or man zcat. The system has been minimized by removing packages and content that are not required on a system that users do not log into. Thanks. I forget what this package is called, but it's like gzcat or something. Either way, cd/tmp cp/proc/config.gz.gunzip config.gz overwrite config vim config. This, by the way, what I'm doing here is how you figure out what build flags a Linux kernel has been configured with. When you build the Linux kernel, it puts and run it, it puts the kernel configuration in /proc/config.gz, and then you can uncompress that and open it with Vim, and you could do like nfs. Kern fs, that is not what we want. Config nfs fs equals yes, and it supports NFS v4, which is the most recent version. So it does use NFS, or I guess you could use SSHFS, but if I recall, llama.cpp wants to use mmap, and you can't use mmap with SSHFS, I think. Or does this port fuse? Config fuse fs is set to yes, so it does. 9p. 9p is not enabled. Gonna file a bug about that. Bug list. Fly user kernels don't have 9p enabled. WireGuard is fucky in WSL. Fucky is a scientific term, for the record. So, I realized that I just did something and I didn't tell you what I did, so I'm going to be more specific about it so that we can have it be a teaching moment. Before I only had one machine in fly m list. Before I only had one machine in the pool for this GPU app. And in order to create more copies of it, what I did is I forked the volume by doing fly vol fork -- require unique zone, so it gets put on a different physical computer box. I set the VM GPU kind for the volume to the A140 GB. I cloned the existing volume that had all the models, and there we go. Fly m run -e o llama host equals http://gpu recipificator dot flycast ollama/ollama, and I'll create an ollama shell just to prove that everything works. I probably should have done this the entire time. Now that I think about it, I could have saved myself a lot of pain, suffering, agony, and networking inside of networking inside of networking inside of networking by just running a machine in the cloud. Oh, I have to do -- shell. I am a genius. How do I tell which machine is which? Can I? Oh god, I just realized that we're not going to be able to tell which machine is which very easily. Cool. Let's kill this watch thing here so that we can let all the machines go to sleep. Let me get rid of that machine that I started that should not be around. Or that mistaken machine that I created. We have to force destroy it. Cool. Why is it defaulting to Newark? It should be going to either Montreal or Toronto. Oh, did I just destroy the wrong machine? I did. Cool. Either way, I'm creating an ollama shell, and we're going to have it do some stuff in a loop and see what happens. While true, do ollama run -rm-i... No. No, why am I doing it like Docker? Fuck. Llama 3.1, why is the sky blue? sleep 2, done. So now we have it loading on machine 9080. And is it going to go to another machine after this? It goes to the same machine. I forget how the proxy decides between machines. What's that one program called that lets you do HTTP requests, but like a lot of them? It's like Hey, right? Yeah, it's called Hey. Okay. I'm going to download this program called Hey, and we're going to do a lot of requests to our llama service. Curl? Oh, right. Apt get install -y curl Jake. Curl-o hey that. And we go over here and chmod +x hey /hey. Perfect. So we want to do hey dash number of requests. We're going to do 500 requests with 3 workers. And we're going to have h content type location /json -d double quote shell curl that on double quote, and then we're going to poke the flycast API generate route, right? Does that sound right? I think it does. So... Oh, it started a new machine. We're doing something. We're doing something. Oh, why did I hit the wrong button on that thing? I don't want to show emotes. Machine exited with exit code 0, not restarting. That's not good. That's very bad, actually. Abandoned thread. Abandoned thread. Let's do one request and see what happens. -n cannot be less than -c. Okay, let's do 3 requests and see what happens. Why is it exiting? And why is it giving no details when it exits? I swear, I try to, like, show off something interesting, and then everything just falls apart. Why does this keep happening to me? Okay. Llama PS is now crashing it. What? But this is actually really interesting to watch, so it's fine.
Good.
Okay, I guess it is hashtag relatable content. I'm doing something
nobody
very
watches
long.
streamers. No one does. No one
It
watches
has stage
streamers
fright. Okay.
just being successful.
I wish I could make the window bigger. Why? Why are you not doing this? What is wrong with you? Okay, if we just curl the top level thing, does that cause it to crash? It does. What? Is this because I forked the volumes? That shouldn't be the case, right? Like, it should support... Okay, now it works? On machine 17816. Okay. No, that's the thing in the logs. That's the thing in the docs. That's the thing that should work. What are you on about, you silicon piece of crap? Yeah, let's look at the API docs. I would show it on camera, but again, you know, OBS died. Asterisk. No, why are you like this? Okay, curl. Okay. I don't have a curl command here. Curl -s data binary at... Oh, right. Curl-o foo.json, and then that... Watch Z slowly go crazy as everything stops working. That's hashtag relatable content. Okay, so this should do something. Right? Okay, that generated a bunch of stuff. You see all these numbers? Those are good numbers. We want the numbers. Okay, so it's... Okay. It is somewhat working. Right. Apt get install vim. Actually relatable and inspiring. Okay, so stream falls. You can't see this right now, but my brow is furrowed to the next freaking time zone. Okay, it summarizes the end of the article, which our LLMs are wont to do, but that means it is working. So I'm just doing something wrong with my benchmarking tool invocation, right? Wait, hold on. Am I just doing it wrong? Number of requests to run. Okay, let's just do /hey. Okay, we get a bunch of responses when we do... Oh my fucking god, I am a goddamn moron. Guess what happens when you try to get a route that expects a post request? It will say 404 not found. Because I need to specify the HTTP method.
You're a pro.
So... Fuck you, computer. Post/API/generate. Okay. -m is the H... Oh, it's because it's Go flags, and I have to put the flags before the argument. You better do this. See? Okay, now we have computer. Now we have computer work. When I was talking with Yvette in our one-on-one yesterday, I said something along the lines of, it is never the exciting problems and it is always the stupid problems. This is another case of it always being the stupid problems, like forgetting to
Oh,
put the right
yes.
HTTP method or putting the command line flag in the wrong place. And
Velspro. See, inspiring. Yes, exactly. Even the greatest make dumb mistakes.
I don't know if I feel very great right now.
Listen, you're goat, okay? You are a goat. Is that what the
Meh.
kids are saying? I have no idea. Meh.
Actually, there's
I
been
just
some
assumed
cases
like
where, like,
20-year-olds are,
there's been some
yeah.
cases where Japanese fan artists have been getting comments that from people saying that they're the goat, but totally misinterpreting it and like deleting their account because of it. Because people
Oh,
they
weird.
thought they were being called like an
No.
animal
Oh
derogatorily.
no.
Yeah,
That's fair.
that
That is
is
very much
very
lost to me.
fair because they're literally translating it with Google
Vet.
Translate or something. But
Okay, so
okay,
it's vet. How's it
so
going?
you see
Yes.
all of the things that are changing in the stream. How it
I don't, but okay.
okay, there you're gonna have to take my word for it that uh there are a lot of things happening on the thing that's doing the thing.
Oh, okay. Yeah, then I understand now. I
Yeah.
follow along. Let me tell you, going in like having just like basic what is essentially like an audiobook accompanying a terminal window is very strange. Very strange experience.
It's like playing the Stanley Parable without seeing it. Have you played the Stanley Parable, by the way?
No, I have not.
Fantastic game.
It's the future.
It is a
Mhm.
fantastic game. Do not Google anything before you start playing it. It's like Nier Automata. You have to go in
Okay.
blind. Or Xenogears. Yeah, you definitely have to go in blind for Xenogears. And Velspera is gonna just be like, yes, or something.
Vet. They said vet.
I mean, I see Velspera there, and I have internet streamer brain rot, so I just read people's usernames.
Okay, that's fine.
Why do I have 19 DMs?
Oh, it's a JRPG?
Xenogears? Yeah,
Yeah, is that
Xenogears
what
is
Oh.
wild. The guy wanted to make a 5-part series, and it was originally going to be Final Fantasy VII, but then Final Fantasy VII's story won inside Square, and then we got Xenogears. God. Okay. Maybe 300 was too many, but I was trying to force this to scale up to multiple machines, but it doesn't seem to be wanting to do that. So, uh, let's look at the documentation to see how... Let's look at the Windows keybinds to see how to not accidentally minimize the window that you're looking at. Fly.toml. Uh, what's it? What's the thing? It's like you set the number of concurrent requests, right? Yeah. So we go in here and we set services.concurrency to type equals connections with a soft limit of 4 and a hard limit of 8. And these are arbitrary numbers that I have just picked out of my ass. But I am attempting to force this into doing more work. So I'm going to have it do 3,000 requests with 20 threads so that we hopefully force every machine to actually wake up and do things. Because our hard limit is like 8 requests per thing, and our soft limit is 4 requests. So once it gets 4 concurrent requests, it will shunt off load to another machine, and once it gets 8, it will refuse to accept any additional work. But things are just crash looping, because why wouldn't they? Oh. Okay. Oh, that is a lot more output, a lot faster. That is a very good thing to see. Okay, good. That is a positive change to the situation. But it's still only having one machine do stuff. That's not what I want. Why is it not doing what I want? Yeah, it's only channeling it down to one machine because the others are just crash looping. Why? I'm doing something really stupid. Let's see how stupid it is. Okay, so the one that works is... Which one is it? Machines. The one that works is 17816. So... can I view the logs for other machines? Dash help. Oh, filter by instance ID. That sounds like a good word for this. So let's do instance ID for another instance. Let's try 148E56. Machine exited with exit code 0, not restarting. Why? This has the debug log is enabled so that it should debug the logs, right? That's what happens when you have debug logs, right, Annie?
I don't know. I feel like it's always hit or miss, and or like if when you do it, it's like it's not the logs that you want. So
Hint, look at your logs and metrics. Yeah, where do you think I'm looking? Is this because I
the
forked
number
the
of times
volumes? Does llama not like it when you fork the volumes? Okay, so the broken instance does have a... Oh. State hydrating. That sounds potentially ungood. Let's destroy the one that's broken. So let's see if the one that's not not hydrating works. Okay, it's pulling a container image. Machine's trying to be reachable. It's not exiting. It's loading. Okay, the volume just wasn't ready.
okay.
Let's try destroying this volume. And let's try reforking the volume. Or actually, fly, scale, count, 5. Does that automatically create volumes? Let's find the fuck out. Oh! Oh, those are gonna randomly fail because, some of the things don't have the models downloaded. That's why you forked the volumes. Oh my god. Ah. I just potentially broke it during a benchmarking run. So we're going to press Control-C several times and reevaluate our life decisions. Let's fly scale count 0. Okay, fly vol list. Fly vol destroy. I'm thankful that the fly vol destroy thing will tell you, like, information about the volume so that you can make sure that you're destroying the right one. This is a bit of UX that I feel that I never had when I did stuff on Heroku. Fork. -vm -gpu -kind a100 -40 GB. So let's fork this. Oh, I have to require a unique zone. Fuck. If you're having trouble differentiating machines, you can just set the prompt. Yeah, but, like, if I'm having trouble differentiating machines, then I'll forget to paste it. And it's not just differentiating machines from the shell, it's differentiating machines from the, at, like, runtime. In logs and stuff. Okay, so we got 295 responses, but let's scale it up some more and see what happens. So fly vol list. So we're gonna wait for these to hydrate. I'm pretty sure hydrating means that it's copying the volume bytes from one host to another. Does that sound not incorrect, Annie?
Repeat it.
A volume in the state hydrating is copying the bytes from one computer box to another.
I don't know what else it would mean. Yeah.
Okay, cool. I don't know how long that takes. Because it apparently takes longer than instant.
What's the size of, like, we only have one model, right? Right now? Or
It has a bunch of them.
it has a bunch of models installed? Oh,
Yeah.
okay.
Yeah,
I mean, I don't
could
know.
just
I don't
re-download
know
the
how big that
models.
is. You could. It's
Oh, I can do it in the stupid way. Are you ready for this? You know how I have this
I'm
program that
ready.
lets me do a bunch of HTTP requests with an arbitrary method in body?
Okay.
So, what if, for the sake of argument, I just have it attempt to pull the models over and over and over and over and over? What could go wrong? A lot of things, yes.
Okay.
So, what I'm going to do over here is vim pull.
I would just wait. It's almost done hydrating. It was like 3 out of 4.
That's because I was
This is
deleting
way
them.
delayed. I have no idea. Oh shit. Okay. God, how delayed is this? I was like, oh, I'm catching up. No, I'm not. No, I'm not.
Okay, maybe this JSON file will work. Okay, and no. Fly vol destroy. Okay, and then fly scale count 5. Okay, we have created more volumes. Cool. So now what we can do is I'm going to open another off-screen notepad window and copy down this command that I have right here so that I can change it for pulling all of the models with a billion T requests. So let's go with, we have 5 machines, so let's go with 20 workers and 100 requests. Is this overkill? Yes. Yes.
Yeah, well.
But as we say in the business, there's no kill like overkill.
Is that what we say?
Sure, let's go with that. Okay, fly logs. Ah, yes, we are getting 500 responses. That is what I want to see. I want to see so many requests that we cause the server to error. That is the correct pro gamer move, right?
We did it.
Okay. I'm getting a lot of 200s that are very fast now, so that's a very good sign.
Oh, okay.
Or it's at least not a bad sign.
Sounds like it's not overkill. It's not overkill. We're not doing our job.
Perfect. We got 32 timed out, and perfect. We have everything doing that. So now let's spread the love, and let's have all of the GPUs think really fast. Oh, there is so much text being generated now. This is good. We are spreading the load out. Oh, let me look at the graph. Is there a graph?
Clear the load. Oh, man.
Oh, there's so many logits. I don't know what a logit is. Let's go to metrics for the last 5 minutes. It shows that there are many HTTP requests going on. That is what I am doing, so we are doing it correctly. I think. Wow, such technology. Yeah, such technology, many broken. Dear God, this is a lot of requests. Maybe 3,000 was too many? Let's change the life decisions a little.
Oh, I'm seeing the text now.
Are these requests being sent in a
Not caught up,
constant
but-
stream, or is there any sort of delay between them? I don't remember, but based on who made this program, I would guess that it's doing the requests as fast as possible, as many as possible.
Mhm.
Okay. Yeah, that did like 190 requests. So let's change this to 100 workers in parallel and 100 requests. Let's just do bam. It would be fun to see a real-time watt usage for the fly machines, lol. Ooh, maybe we can. So, right. I have to do Control B and not Control S. So what we can do is we can SSH into an individual machine. Fly SSH console NVIDIA-SMI. Command not... How is that command not found? Or did I just... I SSH'd into my shell machine. Okay. Gauge from 0 to Jesus Christ.
Jesus Christ!
Yeah, basically. So let's pick one of these machines at random. And, there's this really cool command with the NVIDIA drivers on Linux called NVIDIA-SMI. And what this will do is this will let you get information about the NVIDIA card off of it while it's running. So if I do watch NVIDIA-SMI, we can see that now that it's not doing anything, it's down to like a paltry 39 watts or something. Let's make it suffer. Let's do 10,000 requests.
That's not just the GPU, though, is it?
This is power usage for just the GPU. And as you see, once I started all the requests, I have 79% utilization of the GPU, and I'm using about 220 watts of power. For context, the average MacBook charger is 110 watts. I am using 2 MacBook chargers worth of wattage right now for this one GPU, and I have 5 of them.
Wow.
Yeah, it does.
Wow.
It seems like it's a lot, but it's actually like shockingly little. Like, this stuff does use a fair bit of power, but it's
It's
also
not
fairly
as much
power
as I
efficient.
expected. It's not quite. I think I had it in my head that it was less efficient.
Yeah, but so let's say for the sake of argument that we have nodes with 8 GPUs, right? So
Yeah.
inside this node, we have 4 A140 gigabyte cards that can each pull 250 watts at full tilt. That means that each GPU node is going to pull up to 2 kilowatts for just the GPUs itself. Now, for consumer hardware, this is tray ridiculous. But as far as data center hardware goes, this is actually really, really efficient. Because I've seen some servers with 10 kilowatt power supply units, and 4 of them for redundancy. Yeah, like,
Mm.
yeah, as Josil says, for a server that's nothing. Yeah, like for home usage, like this is somewhat insane, but then again, I'm speaking as somebody that
Yes.
has an RTX 4080 in their tower. Yeah, like my GPU in my tower can pull 320 watts. Which means that technically my GPU in my tower can pull more wattage than these GPUs, but my GPU is a
Way to
graphical...
show off.
I mean, my GPU is also a graphical processing unit that can process graphics.
That's true.
Yeah, because the A100s, they have no display hardware. They have no process. They are graphical processing units that cannot process
I
graphics.
can process graphics.
They cannot run Crysis.
I'll be honest, I don't like the term GPU. I mean, I know it's like whatever. That's the name we landed
It's more
on,
of like a tensor acceleration unit or something.
yeah, that doesn't have the same ring to it, I guess.
Yeah, there's also people have been using the term TPU for this, but
CPU.
tensor processing unit.
Oh gosh.
Yeah. Oh, we are at time.
Yes.
Well, what did we learn today? We learned
What did
that
we learn?
I'm bad at networking.
OBS is hard.
If OBS crashes, do not touch it.
Great. Great.
That horizontal scaling of large language models is basically the best way because, to a point, horizontal scaling is the best unless you are in an environment where you have multiple GPU models to pick from, and even in AWS, that is not the case. Oh yeah, like GPU model, like horizontal scale or vertical scaling of GPU models in AWS is hard. When you're deciding what you want to do, you need to decide what your trade-offs are, and if you want to scale on latency or throughput. And has it not actually updated the terminal in a while on the stream? Because I'm seeing the preview and it just says Llama run Llama 3.1.
I don't know what other people are saying, but it's like there's like a 1 to 2 minute delay.
Oh,
so I'm
okay.
unsure.
Okay. Oh, okay. So it is showing things correctly. Okay. I am flying blind here, like, way more than usual.
It's fine. I'm even more... I mean, I've been delayed for many minutes at this point, but I'm able to loosely follow along.
Okay. So, also, the parameter count times the parameter size plus 30% is the amount of VRAM that you need. If it's 13 billion parameters or less, you can put it on any fly GPU. If the model is larger, then you start needing to get the bigger GPU or making compromises in terms of quantization.
Something we haven't really touched on. You know what? Nope, I'm gonna zip it. Nope, not gonna. I need to eat lunch. I'm not gonna.
Oh, you're not gonna nerd snipe me?
Nah, no, because I'm hungry.
Okay. Yeah, and you have to set your service level objectives and decide what compromises you want to make. Uh, Also, I mentioned this, but I didn't explain it in particular. The attention window is the amount of state that is needed to actually do the inference. It's called an attention window because everybody copied this one paper by Google titled "Attention is all you need," and that's why every single large language model and AI paper has like "X is all you need" in as the title.
Mm.
Because computer scientists are try to make jokes and they are very bad at it. Anyways, I think that this is a success of some kind.
I would call it that. Yeah. We've had some successes.
We've had at
So,
least one success here, and one of the
one.
successes is that oh, the benchmark is still running. Cool. I wonder if anybody on NetOps is going to notice this. Thank you, says Mr. Interestful.
Thank you.
Thank you for
Thanks
watching.
for tuning in.
We'll stream some more, I guess.
Yeah.
We're
Oh, we definitely will.
we're probably going to be streaming more on YouTube because we're about to break 2,000 subscribers, which is wild given that we were at like 500 subscribers a month ago.
Like a week ago. It was like a week ago.
Really?
Yes, really.
Jesus Christ.
Yeah. It's insane.
I think we're doing something right.
Yeah, I would say so.
Either way, stay frosty.
Thank you, Vet.
Chill out, and don't forget to stay hydrated.
Yes.
I'm going to pause
talk to you guys later.
You can disconnect. I'm going to pause for like a minute and hit end stream so that people don't get randomly cut off.
Okay, cool. Well, I'm gonna bounce.
Have fun. So I'm gonna hit the end stream button now. Let's see if everything breaks.